All right, it's G back with you again, and this time I'm going to try not to screw you up so bad. So hopefully you're staying safe and things are working well. Again, review questions at the beginnings of these are really super important to give them a try. Usually they cover something that came from the past, and you have to determine whether or not something is an inverse or something that came from a previous section. Usually the second ones or third ones revolve around ideas that we be talking about in the lesson today. So to keep the videos relatively short, let me kind of focus on what we're getting done today. Finding the vertex, we're going to be really talking about some quadratic functions today. So finding vertices, finding the vertex, finding the axis of symmetry, finding the roots. These are going to be all things that are very old hat for us, and we should be able to do relatively well. Finding the vertex of this particular idea, since it's already in vertex format, relatively easy to remember that we always take the opposite of our h's. That would be -2. And the outside component k stays the same, so the vertex in this case would be -2 and 9. Now it does say some other things about this. The a value does give you an idea of how skinny or fat the graph happens to be, and the negative value that's in the front basically tells you that this graph would be an upside down parabola with a relatively thin idea that goes with it. Okay, so that kind of brings back some memories about vertex formula. Now, third one here, what's the formula for the x coordinate of the vertex in the quadratic model? So if you're looking for the x coordinate in the vertex, well, since that vertex is sitting right here in the center of the parabola and right straight through it happens to be the axis of symmetry, the x value would be equivalent to that wonderful equation, -b/2a. And that would be the way you'd find the axis of symmetry. So this x is the same as the as, or the axis of symmetry. Now, this should be old hat stuff that we've seen many times when we were in Algebra 2. And I'm just going to kind of remind us of the different formats that we're relatively looking for and what they're good at, and how you can kind of go from one to the other. Vertex form, of course, really super good at finding h and k. H happens to be the axis of symmetry to as well, or x in this case, -b/2a. So some really good things that basically come out of it. Now, some things that the vertex form is poor at is that it wouldn't give you any things like the y-intercept, it would not give you roots, and so forth. So it has some deficiencies. Standard form, probably the one that we're most familiar with. When we write most of our quadratics, we put them in standard form. It's probably the least helpful of all the cases. It really is pretty decent at finding the axis of symmetry with -b/2a. It also happens to be pretty good at finding the y-intercept, which happens to be the c value in this particular case. It does give you indications of up or down and its width, but primarily it doesn't do a very good job of finding the vertex and roots in that particular regard. Now, intercept form, or sometimes referred to as factored or root form, this one has all the ideas that it's been factored down, so it finds roots relatively easily. Whatever those two roots happen to be. It's not too bad in finding the axis of symmetry, which is directly between these two roots is where the as is, which helps you find x. It just really stinks at finding the vertex. Now, to go in between each one of these, you have really kind of some ideas like standard form to root form. You would factor it. If you wanted to go from root form back to standard form, you would FOIL it. If you ended up wanting to go from vertex form to standard form, you would just expand the idea by expanding the square. And if you wanted to go from standard form back to vertex form, you would complete the square. So we've done all those particular techniques, and you know all of their individual strengths and weaknesses. Now let's just put it to the test. I think this is some good stuff for you. Now, finding the vertex for each following one, you're going to pray that they're all in vertex form, and it looks like the first two absolutely are. So once you get the vertex, that's basically the idea. Hold on a second. V, I'm going to erase that, put my stuff in the wrong spot. That's -2 and -9. And since the parabola is an upward parabola, that vertex would be at the bottom of the quadratic and ultimately would represent a minimum. It's the lowest possible value. Same goes for this one. Vertex would be 8 and 11. Parabola or quadratic would be going down because it's negative, which would end up making it a maximum. Now, what you're going to find out is you're going to run into issues as soon as we get to standard form. This is in standard. And as soon as we get to standard form, it doesn't work as nicely to find the vertex. Now, what you can find is you can find the x-coordinate by using negative b over 2a, and then a little plug and chug will help you figure out what the y is going to turn out to be in the end. Now, let's see what x turns out to be. That's negative 12 over 2 times negative 3, which is going to be negative 12 over negative 6, or 2. That's fairly nice. So our vertex is at 2, comma, and if we plugged 2 back into the function, we'd get negative 3 times 2 squared plus 12 times 2 minus 7, and we got 4 negative 12 plus 2 times, that is 24 minus 7, and from left to right, that's going to be 12 minus 7, which is 5, and our vertex is going to be at 2, 5. Now, is it a min or a max? Well, the parabola is a downward parabola based on its negative value of the front coefficient, so ultimately it's going to be a max. See, standard form, it's more work, but it's doable. You can get it done. Now, if you were looking for the vertex in a rooted or factored form, then ultimately I would say go get the roots first. And those roots would end up being 14. I don't know why I keep drawing parentheses. That's weird. They would be 14 and they would be negative 6. Now, on a number line, or I'll just put it on a graph, you've got 14 over here and you've got negative 6 on the other side. The axis of symmetry has got to be somewhere directly in between. So if you averaged these two values, added them and divided by 2, you'd be getting 8 divided by 2, which is 4, and that would happen to be the first part of the vertex. It's the axis of symmetry. It's somewhere over here. It's really not the best picture, but you get the idea. Now, how are we going to get this value? It's plug and play, just like we've done in the past for standard form, and we'd get 4 minus 14, that times 4 plus 6, which is going to be 10 times negative 10, and the answer is going to be a negative 100. And there you go. There's your vertex. Now, what will it be, a max or a min? Well, if you foiled these two together, you'd get an x squared, which was positive, and ultimately you'd get a parabola that goes up, and the vertex would be a minimum. Okay? Pretty straightforward. We're 8 minutes in, and we are kicking butt. Good job, Huskies. Woohoo! Find, for each one of the following, label the vertex, the graph, and state the range. And it says, what is the domain of all parabolas? Well, since we're talking about parabolas and they're going this way, domain-wise, left to right, they're going to cover all the domain. And this is a good time for us to talk about the fact that we are going to cut ties with the ARN kind of concept and really start focusing on stuff that we'll see in calculus, and that's interval notation, which is going to mean that this is going from negative infinity to infinity, okay, for the domain. Now, the range, on the other hand, will be a slightly different question. Now, what I'm going to do in each one of these is I am going to graph, I guess we can graph these as we go. So vertex is going to end up being negative 1 and negative 1, negative 1, negative 1. This graph is an upside down one with an a value of negative 1, so it goes down 1 over 1, and this is our parabola. Okay, we're ultimately looking for a sketch. Now, based on that particular idea, there's your vertex. Label the vertex, graph it, state the range. The range in this case is going to end up being, and I erased that for a reason, because it's going to be from negative infinity. Remember, we do interval notation. We go from left to right for domain and bottom to top for range. So this would be from negative infinity to the number negative 1 inclusive with a square bracket. Or if you were doing the old notation, it'd be all the y's are less than or equal to negative 1. Now, standard form, a little bit more work. Ultimately, we're going to be talking about trying to find the axis of symmetry, or x is negative b over 2a, or negative of negative 8 over 2 times 4, and that would end up giving me 8 over 8, which is 1. So the vertex is at 1 comma. Plug 1 back in this bad boy. I'd end up with 4 minus 8 plus 1, which is going to be negative 4 plus 1 is negative 3. And the vertex is going to be at 1 and negative 3. 1, 1, 2, 3. Now, in terms of the next coordinate on the graph, I'm actually going to use another little piece right here, which is the y-intercept. The y-intercept is at 1. And since the axis of symmetry goes through there, it's got to be on the other side. And I didn't have to do that rule that I never remember about how to do the width, which you probably forgot too. I don't like that one. Later on, we talk about parabolas and we figure out how wide they are using the focus, and it works way better than that stupid stuff in Algebra 2. But generally, that's the premise there. The range in this particular case would end up being from negative 3 inclusive to infinity. And keep in mind that soft brackets will be on the infinities because you can't reach infinity even though you may be Buzz Lightyear. Basic rearrangement of this particular question, negative x minus 4 quantity squared. I'm just going to move the 2 over here to the side because it ends up making the vertex extremely easy to find. The parabola goes down too as well, and it has a nice xa value of negative 1. So let's see what we got here. 1, 2, 3, 4, 1, 2, down 1 over 1. The graph looks like this. The range would end up being, and I did brackets again like I should have, from, I had it right, negative infinity up to 2. Closed brackets. If I'm doing a rooted question, the best thing you can do here is find the actual roots and get them on the graph. There are already 2 freebies. That's negative 1 and 3. Put those bad boys on here, negative 1 and 3. There's your roots. Halfway in between those two has got to be the axis of symmetry. So I know that the x in this case has to be 1. Pretty simple concept there. Vertex is 1 comma, and plug that back inside there, and we're getting negative 2 times 2 times negative 2, and ultimately we would get 8. 1, 2, 3, 4, 5, 6, 7, 8 off the graph, and it does have a negative, so it does look like the graph is going the correct way. Boy, that is a real bad one. Wow, way to make fun of me for that one. And the range in this case would be from negative infinity to 8 with an inclusive bracket. All right, how we doing? We doing okay? Maybe mins and maxes on these might not be a bad idea. That one's a max. This one's a min. If you're asked those kind of things, I think you can get the hang of it. That's a max. This is a max. You're on the right boat. This should be all old hat stuff. And if you're struggling with this, seek out your teacher and help them get you through it. Find the min or max on these. Mins and maxes are going to be basically based on vertices. So I would say the easiest way to take care of this guy would be to, I'm going to factor it and get x minus 1. And ultimately those two roots would be 0 and 1. And halfway in between those two would be 1/2. So the vertex is at 1/2 comma. And if you didn't do it this way, you probably grabbed your calculator, you cheater. And now you would plug in the 1/2 back inside there and see what you got. And it's really not going to be pretty. 14 times a fourth, because that's what a half is squared, minus 14 times a half, which is going to be 7. And that's going to be 7/2 minus 7. Yuck. Another name for that is 14/2, or negative 7/2. And in this particular case, that's a parabola had a coefficient that was positive in the front. Ultimately, it would be up, and it would be a maximum. Okay? Write the equation in standard from, that's funny, form if it looks like the following. V is equal to 3x squared, same steepness, but has a vertex of this. Well, the steepness would stay the same regardless. We would ultimately have a function that's y equals 3 times x minus 14 quantity squared plus 14. And we would have, that's vertex form. We want it in standard form. Now, ultimately, we're trying to find a way to expand this concept to put it into standard form. You'd have to expand it. That's 3 times x minus 14 times x minus 14, all plus 14. And you'd have to FOIL that. I'm not in the mood. Let me do that real quick, and then I'll do some magic where it shows up. And poof, there you go. I did the work. It wasn't fun. You guys are going to be great at this. This happens to be the 2.2 notes for this, and ultimately you should push on to the 2.2 homework, which is out of the book, and make sure that you're checking your Teams page to be able to find your homework values, which ones you need to be doing, and more importantly, I believe we've added on the homework pages from the text, so it's all digital there, and you can go ahead and take a look at those. Make sure that you're copying down your problem and you're showing your work so that your teachers can give you full credit on your homeworks throughout this particular unit. Enjoy your evening, or maybe this is your morning, or maybe you're still asleep, but stay away from COVID. G out.